Okay, this is these are our fingertips, and I'm going to show you how they deteriorate and how they're built and the whole 9 yards about it. Now, they've been some have been CAT scanned and some have been DNA tested, and they're human, and then that's just a fact. Now, Jesse Garant and Associates out in Michigan and Canada, they did the CAT scans and did the 7 CAT scans for us. In the interest of science, helped us out. Absolutely fabulous people, and the software was unbelievable. The product is incredible. They scan racing engines for defects and industrial equipment, so they can penetrate these things. No problem for them. Nobody else could do that. University of Texas was a waste of time. We went down there, just wasted our time, and it was an absolute nightmare experience. Jesse Garant, you ever want trouble, want help with something and you don't want trouble, go to Jesse Garant. Case closed. Now, this is a fingertip, and Jesse scanned this for us in the CAT scanner, and it shows the nail bed where it is. This is the areolar tissue. There's where the bone is, and all of the different, these are the pads that are on your finger, and I'll show you later how they deteriorate and when you can actually see those pads. Apical tuft is there, which is this thing right here. It sits right on the end here, and all the little tendon balls invest in there. Whoops, can you see that? Yeah. All the little tendon balls invest right in there as these little straps come down and they tag in there. All right, now, so this one here is almost complete. Now, you get to where the top skin wears away and you down to the basement layer. This is where the top stuff's gone. You see, that's where the basement layer is. And then you get into the fleshy stuff and the connective tissue. You see that little ball right there? That's that ball. They all do that. I don't know why. But they all have this little ball on the end. Now, so, and this has the bone right there, and it has all the same articulations, only it's still coated with the tunica, they call it. Now, let me show you something. You see this here? You see that bump? I don't know if you can see that or not. This right here, that strap right there. They all have that on these fingers and toes where they wrap around the bone. This one has here too. It's kind of hard to see, but you can see it. It wraps around with that tunica, and I find it on all of them until they get deteriorated so badly that you wouldn't hardly believe it. The strap is still there. But now, so we had this one. We went down to the one that had the basement layer. Now we got down a little in that same area, but now it's already down to where it's showing up with the what they call, these are plagioclase, and these are the tendon investment balls. Now, you see down here? You see that black dot and the clear dot there? Okay, that's the vein and that's the artery. This is a tendon emplacement. They come down in pieces, and all of these grippy little things here, the plagioclases, invest in these balls in here, and then you have a layer. Now see that right there? That is blood. And it will turn red in a second. They rehydrate. Now what happens here is that tendon strap came way over here, and I snapped it off, and the ball goes right down in here. All right. So this one here, as you can see, it's the same sort of structure, and then it's the same sort of structure as this one right here, which is eroded more to a point where it's I think this is came through the atmosphere and combusted in the atmosphere, because all of the meteorites that come through space are meat. They're body parts. I'm telling you, it's a fact. They have veins and arteries. Now, so let's get down to this one here that still has the tendon balls, and it still has some skinnish sort of stuff on here, and we can see the vein and artery. Now, then it goes a little further, and it depends on the kind of area that it's been preserved in. Now, this one here has gone down to a place where all of the surface stuff has eroded away, and you're down to what they call mud rock. And mud rock is literally flesh. It's the literally deep flesh and it still has little bits and things of connective tissue going through. That's where the actual bone structure is underneath. That's the vein and artery, and you can actually see the vein, and the veins normally don't blow out. You see that? That's where the vein would have blown out. There's right there. And there's another one up under here, but this is also, this angle is where the tendons invest to make your finger go. And then the artery side, you see, that blows completely out. See, this, what happens is your fingers, it feeds up one side, the artery, which is the red blood, and it squishes through here and it comes back through the vein side. Now, and normally you're flush with blood, so they're just pumping blood everywhere. Now, that little black thing there, and hold on, I want to show you something. This is so cool if it'd do it. I'm going to get this thing wet to show you something in a second. Now, look up over here. You see up there? That one right there? You see the tip? The little tip thing right there? That's the apical tuft. And that apical tuft, I'm sorry, that's the distal, that's the phalange, the tip of the finger. That's the tip of the finger. They call it distal phalanges. Now, it's the very, very tip of the finger, and that tip is that bone blackness that you can see right there in this bone. Now, well, this fingertip. Now, because bones don't get saved in mud fossils. Totally opposite of what they're doing in dirt. Totally, it's 100% opposite. The flesh gets saved because it's encapsulated, and when flesh stays wet, it thinks it's still alive. As soon as it dries out, that's when you got the trouble. The bones, when they're dry, they turn into stonish things. Now, when they're in the wet, they get invaded. It's this processes, nucleophilic invasion, and all kind of things like that. But they get replaced. Something goes in there and says, "Okay, get out of here. I'm coming." That's called a nucleophilic invasion. It says, "I want to come in here, and you're going to have to leave," and that's what happens. Now, this, as I said, that is the bone black, where the bone is inside there. Now that's called ferritins, and they're FeO2. Leaching out of there, the black. Now, this black is the same thing. You see that? And they leak through, plant tissues and animal tissues, and that's it right there. I washed that 1,000,000 times, so you can hardly see it. But when I first had it, it was black. Now, this little tiny finger here, look. This is also a little tiny finger. You see it? Look. See the two blood vessels here? It's an identical same finger. It's transitioned all the way down there. And if you can look in here, you can actually see. Whoops! You can see that same pattern inside. You got to get it just in the right way, in the right light. It's hard to see, but this is another fingertip, and they transition all the way down into like here's some toes. Look at this. These are toes. Let's see if I can find you. Let's see. Well, they start out like this. This toe is not fully transitioned at all. You see that? That was the shiny stuff there. That is the toenail, and that black is the toenail, and the red behind it is the blood. This heavy blood in all your digits. Now, look at this. This is the guy's toe, and that's his toe. His what do you call it? The callus on the side of his toe. Nasty looking thing, and that's a big toe. Now, here's another one. That's the toenail, and here's another one. And here's the toenail. See it? Look at that. That's the toenail right there, and there's the blood under it. And this one here has transitioned quite a bit. And there's your red and the black for your vein and artery. And this is the scruffy stuff on the bottom. You have what they call grip skin. And there's a lot of this silicone in there. It's tough. Now, things do erode away, and they change in different ways depending upon the pH and how much water is in this, percolating through and all that business. So it's pretty tricky to just see something and know exactly what happened there and what it is. But I've seen a lot of them, and I know pretty much what they are. Now, there's another toe. See that? There's a toenail. Isn't that something? And this one here, and there's some of the little grippy stuff down the bottom still there, and that's just what it is. And I got a lot of them around here. But anyway, so now we're down to That's how. Now here's the one that is the one I want to show you. Now, this one here is another fingertip, and this is that right there. That ball, that circular ball there, is the tendon that digs in and holds so that you. This little, see that little stalk? Hold on, where? You see that little stalk right there? That stalk runs from this ball and up over the top like this and into this strap. You see that? That was a strap, a tendon strap. And that strap ran back. And there's a million of these things. A ball here, a ball here, a ball here. They're all over here. There's a ball here, a ball here. That one there's a ball. And that one there has that structure of, they call, they're showing something on the internet that's it's got all these little lines through and forth, but that's what's inside of these things. If they deteriorate the right way, they have this lattice-looking squarish. It's like rebar in there, and that's what people are claiming on the internet. They're seeing these things and say, "Oh, that's some kind of building material," and it's not. 99% of everything you're seeing that's built in the world is they just picked it up and used it. I'm not kidding you. They cleaned it up a little bit, but not a whole hell of a lot. And so anyway, this I think was obviously combusted from some reason. So I don't know. That's just what it is. Now, so anyway, these are all fingers. That's just what. Now we went through the toes. Now let me show you something else. Once you get deteriorated on these toes, they actually end up in a silicon state, and I don't know why. Some of them do, and not all of them. I still can't figure this out 100%. But see that? That's that little ball. That is that little toe, that little fingertip ball, see it? That's it, it's the same structure. And there's red in here, that is the same thing as this. Now, for some reason, this one turned into really raw silicon. This is very, very unusual to be. You see that? That's shiny, and you see the red in there? Maybe I'll bring it over to the scope. But you see the two little holes in the bottom there, the red and the black? That's your vein and your artery. It's just what it is. I don't know how they end up transitioning this way. You see this one here? All those little red dots there? Those were the blood vessels that were underneath the guy's fingernail. You see that? Or his toenail. That's all I can say. Now, I'm going to go over to the microscope and show you something that really blew my mind today. Hold on a second. Okay, I'm on the microscope here, and whoops, hold on a second. This particular shot is of that real silvery looking one, and it has it's just what it is. It's hold on, let's see if I can focus this in. It's a very shiny metal silicon. Now the other one is this one here that had the little blood vessels. See the little blood vessels there? Now that's a normal blood vessel. And you see, but behind it is all that silicon stuff. Now I don't know what that's about. Now these other ones have still what they call fibrin, I think it is. Fibrin is the backing of, it's like a clotting fabric that's on blood cells. And you see that right there? You see that pattern of all these little liney looking things here? That's one of the grabbers that is for your tendon. What I was talking about before, the things that they claim are structural. Anyway, that's what this is. Now, so that was those fingers. Now, I got to show you something here that's going to blow your mind. Well, it blew my mind, I can tell you that. Now, let me show you here. I have the Rosetta Rock, which is this one right here. You probably can't see that. Hold on. That is the Rosetta Rock. And that one there is, what this is a giant toe. And that's the pad under your toe. This is the grip skin. Let me hook in here. This little flaky stuff is the grip skin. And if you could see, there's like little fabric things coming down that invest into those tendon balls. This is the tip, the back, and that's your vein that's going in there. The arterial side is over here. The bone is in the middle. And that is that strap. Remember I talked about that strap before? All of the toes and fingers have them. That strap is where the thing wraps itself around. And you are literally built in blocks and straps. You see that strap and the crack going here? There's cracks. You see that? I don't know if you can see these things well, but I can. And they are made. You're made. See that? There's a seam that runs right around there. There's a seam that runs. See that seam? It runs right around the front of your toe. And you see these straps running up here? Those are the straps that run up to the tendon balls. Oh, this thing's heavy. That are in here. There's tendon balls right in the end of your fingers. See that right there? There's one right there. They're all over in here. This has almost everything still on it. There's an actual fingernail. I mean a toenail. There's a toenail, and there's the guy's callus. Look at that. Look at how ugly that thing is. It's nasty. And that callus is loaded with minerals. You see, there's the strap. You see this red stuff? That's the blood of the arterial side, the reddish stuff. Normally that would blow right out of here, but this thing is like a cap over here, and it did the exact opposite. That almost, I've never seen this before. This was like a clamp over the top of the holes, which are these. Hold on. You remember this puppy here? Okay. Can you see this stuff? No. Hold on. Let me drop this down a bit. Give me a second. Hold on to yourself. Here we go. Now, this is where I showed you before. That's the fingertip, and that is the arterial side that blows out. And here, here, and here. And as a matter of fact, that is my logo on my fingertip on my Facebook stuff. Now, there's the bone. We talked about that before. There's the holes, and this is the vein side, which has clamps built in, so they never blow out. However, this time, the arterial side, which usually explodes and squirts out of here, soaked in here a little bit, but this side exploded. This is the black side, and never ever do they turn black like that. They almost always seal off, and they just look like normal flesh. This time it blew out the blood, which is the black blood, which is the deoxygenated FeO2 it's called. Blew, hold on one second, blew right out the back. I mean right out these holes. And that would have been well, they are here and here. This is where they are. And there's one up at the front too. And it just forced them to come out of here instead of the other side. Now, look at this. This right here is the skin that is on the inside of your big toe. See how crazy it looks? You see it? And you see these little red dots? That's blood. And one of them is growing. It started growing after it started seeking out of here. I'm telling you, I'm going to show you in a second. The microscopic shots of it. It's very, very strange. Now, here's another one of those balls, and there's balls all over the place. Those tendon balls that invest I showed you before. That is a pad on your toe. If you go to the inside of your toe, you got this little gnarly looking pad here. And that's what this is, a big toe. Anyway, so I'm going to show you what is growing on here, or was growing on here. It might be knocked off by now, but it's, hold on, it's up here. Let me go back up in the sky, hold on. Fasten your seatbelts, ladies and gentlemen. Okay. We are at cruising altitude. Now, here we go. I'm going to show, well, let me shoot this off. And we'll come up with this and pick it up. Oh, now, here we go. Here we go. Whoops, wrong mouse. Alright, here it is. I'll start from the bottom. Now, this is a shot that, these are all microscopic shots I was doing this morning on all different types of specimens. So it's sort of random going here and there. But this is from the Rosetta Rock. And It's got, you can see it's all kinds of crazy minerals and everything, and that's the way life crystallizes, and it's because of the transition metals. I keep saying transition metals over and over, and they claim they're just trace elements. That is the only reason you're alive, is transition elements. All right, transition molecules. Now, here we go. Here's some more transition stuff. Anytime you see colors, reds and greens and yellows and all that, they're transition metals. And they do the job of carrying around the food and the oxygen, getting rid of the carbon dioxide, and they travel through your body, and they dump stuff and pick stuff up. That's how they work. And that's why they, here's another one of, now you see these little fibers here? Well, first of all, that's a blood vessel under it. It's transition. The black is ferrous oxides. These are what they call keratin fibers, which are the fibers that are collagen type 1, which is it's a mineralized connective tissues, and those are in your grip skins. When your grip skins are your your feet and your hands and so forth. Now, this one here is another sort of that. I take a lot of pictures sometimes. This one here. This is coming out of here. This was, I believe, an artery, but that's the outside. It goes back about here. So it's like the vein or artery is sticking out, and it became open, and then it fills up with silicates. That's the way that it happens. Now, let's see what else we got here. All right, now here we go. Now we're getting into the Rosetta Rock. Now this is what you call one of the blood vessels. You can see the brown blood that's still in there. Now let's go up here. Look at this. You see that? You see, this is a normal vessel. It's a regular normal blood vessel. That's the blood that's inside. It's congealed. That's just the way it works. And something seems to be growing out of these things. You see that one? Now look at this. Look at this one. It's just amazing. You see that? Oops. I don't know what to say. You see that thing? Now, I don't know. I don't know what to say. But that's it right there. It's what it is, what it is. Now that's the normal one. And there's this one. Oops, I do this every time. You see that? You see that? You see that? It is strange. About as strange as I've ever seen. Now, I believe this is coagulated blood. And this is the blood vessel, you know, the walls of the blood vessel. And they don't deteriorate, man. They last forever. And as if they're in wet, and especially if they're in a salt wet, it's really, really incredible. Yeah, I'll show you something you won't, well, maybe you believe it, maybe you won't. But I'm going to show you something, uno momento. Well, yeah, let me go back through these things before we get out of here. And then I'll show you the rest. But I don't know what to say about this. I really have no clue. Now this is a dinosaur egg that I found. That's the outside of the egg. And of course they gave me a hard time about that. That's the inside. And it's a life. It's an absolute life. That's the inside of a dinosaur egg. Now, this is from a blood vessel, from a geode. Now, I mean, geodes are from living creatures. That is a blood vessel. That's no question about it. That's the outside, and that's the inside, like I was showing the other one. You can see they have the same looking architecture. Now, they say this is a smectite and it's all this and that and it's just normal, natural. They really don't pay much attention. Now, this is the black stuff, which is the FeO2, which is on that same geode, which shows that it was from life. And this is old red sandstone, which is really not had anything to do with sandstone. That's not eroded anything. That is flesh from an ancient creature. That's just flesh. This is all kinds of gook that pushed together, but this is a fingertip. I'm going to show you something that's really going to be crazy. There's some more. This is the way flesh petrifies, and as it petrifies, it does what they call sublimation, which means these things turn more and more and more into minerals. Well, here's one that's turned into a lot of minerals. You see, this is, and there's blood vessels right in this one. They're black, and you see that red there? Whoops, see that red? And all these crystals, that was all part of a creature's body. I'm not sure what it was, but there's always blood in the soil. Anyway, let's go back to this. So we're looking at things that were alive and now they're petrified. And they go through different transitions. You see that thing? Whoops, it's still wet in that one spot there. Yeah? Now, up here, this is the way sometimes they get gold, sometimes they get pyrite, sometimes they get here and there. Now, look at this. This, I am going to tell you, it blew my mind. Now, this is a fingertip. And these are the fingerprints. I'm telling you, that's a fact. That is like the finger tissue, the top layer of finger tissue. And then it goes down into the basement layer underneath, which is all mineralized and so forth. But these are the fingertips, and the blood vessels supply them inside the tissue. Now, I was looking at this, and I'm looking, I'm thinking, look at that. I think that has something to do with these cart ruts. Maybe. I'm just saying. Who knows? I would look at it in that vein and see if it has what you're going to look for in here is the signature of these little black dots, which are the silicon grip skin. It has the silicon fibrils in there, and the Stonehenge is 100% giants, and a lot of those straight up things are exactly like you just see right here, exactly like that, about this wide. And they go all the way up 20 feet, just 3 little strips of a fingertip. I'm telling you, that is a fact. And I have a video on Mud Fossil University. Here's that thing a little in a different shot, but very, very close. And then this is something else, I forget. This is it, but you can see the strappy nature of life. That is the fibers of fascia that coat everything, and there's a blood vessel in there. Another blood vessel, a deeper shot of the blood vessel, and they all go down every which way and tunnel around, and that's the way they work. They got to get blood to everything in your body. Now, this is a tendon at the end. This is where it comes. That's the end of the tendon. This is all the fiber stuff that's around, and then you get into the really, really tough stuff, into the olivines and so forth, to where it leads into the plagioclases. Now, you see this? That is a blood vessel, and they're all over this little thing. And that is this little fingertip. Hold on. I have it around here somewhere. No, I can't seem to find it. It's a little, it's completely eroded down to nothing, but the blood stays. Because bodily fluids last forever. Oh, it'll last, yes they do. They last forever. Now, this is just something else. That's all the black is the bodily fluids. That black is blood. This is as they continue to transition. They take on this iridescence and really exotic-looking crystals, and all kinds of different colors and so forth. And the reason is because of the transition metals. You see that? That's a deep shot into a bone foramen. And here's some, those are the lobes of a lung, and that's the red blood that's in the lung that had been oxygenated and getting ready to go down to do its job, and there's a bone foramen, bone foramen, bone foramen. These are, whoops, these are on the lung on the deoxygenated side. They're starting to pick up, dump their oxygen. They're starting to dump their carbon dioxide. And same thing here, dumping carbon dioxide, picking up oxygen. There we go. Now this is crystallization. It just happens as they deteriorate. That is the dinosaur egg. That is a lung. And what happens in the lung, you get all of this, so they call them chondrites, chondrites and chondritic meteorites. They have all of these different colored things all in them, and then they will be infused with iron oxides because they're blood. That came out of a lung. And here's what the lung looks like when that's got some water in it. And the stony parts of the lung will pick up the water and get this darker looking color on it. That could have started out real pink and yellow and green. I mean, they have all kinds of colors. See, like that, look, see, there it is. This is one that I didn't put any water on yet. And it has all kinds of colors in there. And they're very cool looking. Now that's a lung, and each one of those is like a lobe, and as they start to transition, it's all transition metals. That's what does everything in your body, and they think they don't even pay attention to them. I don't think they're paying attention to them. Certainly not the way they should. And here's the same thing. There's a lung, the inside of a lung. Transition metals doing their job. Anytime you see colors, that's what you got. See that? Leaking blood right out of there, one little spot leaking blood. And I cut a rock one time, 4 or 5 years ago. I sent it back, I cut it, I washed it, I put it down, I looked at it, just sat there. I came back about a half hour later, I looked, and there's one, just exactly like that. Only it was a perfect round red spot. I started screaming, holy smokes, there's a ruby in here. So I wash it, and it goes away. So I come back in another half hour, it's back again. The blood leaks out of these things, I'm telling you, and I mean, it will leak a lot. Now, this is one at the top of one of those geodes. That's not a geode. I mean, I don't know what they think they are anyway, to be honest with you, but they're nothing to do. This geodes now, I figured out, at first I thought they were bone balls, and some are, I know, because a bone ball will boil out the soft, spongy stuff inside. There'll be some metals left inside. Percolates will come through there in these geothermal areas, and the metal seeds that are remaining in the soft bone that had been boiled away are still inside that cavity, and then they start to grow like rock crystal, rock candy. Now, this is also does the same thing. They will leach the center out. Now, let me show you what this is. This is a geode, and that is around here somewhere too. Well, I'll tell you, hey, here it is. Alright, here's what's going on here. This is the geode. Now, you see this bone cap right there? We're going to be looking at that up on the screen. Now, that bone cap is literally a tendon ball. And that tendon ball has these layers in it, you see? They'll have layer, 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 layer. And I found them, they're all over the world. These are the things that invest your tendons into your fingers, into your fingertips. Those go into those little tiny holes, they call them tuberosities. And they're on straps, and they're little tiny balls, and they dig in all over, and that's what these are. And then in certain conditions, the inside ball will become washed out. And I believe it's got something to do with fluorines or fluorides, or it's something to do with an extreme chemical interaction that just somehow eats it away. And I can show you why I can say that because of this. Over here is a tendon emplacement. This right here is how they work. They go right in. This ball snaps right into the side of the fingers and everything. That ball. And I have other ones like that are the same deal. Now, inside here, you see how all those holes are in there? Those holes are not supposed to be there. Something happened to leach that out. And it leached it out. You see from the end here? Those are the little straps that ran down in through this tendon ball to this end of the ball. Now, they are not supposed to leach out of there. This was in some condition that allowed those things, that one particular stuff. You see, right in the middle of everything it leached out. Now, how did it do that? Well, it leaches, I don't know. Well, and I'm not sure what the material is that leached it out of there. But that is the same type of connective tissue that's in these balls that I'm talking about. Now, here's one that didn't leach out. This one here, I cut. You see, I'll show you the tendon balls. You see that round ball? That goes right in, boom, and it locks in, and then the strap comes back and does its job. But this, and when they petrify and in the mud fossil conditions, sometimes they turn into this olivine with these little plagioclase, little white things. You see all that little shiny stuff? The shiny stuff is what was removed. The little tiny flaky shiny stuff you can see maybe. I don't know if you can see it or not. I can from where I'm looking, but the little tiny like smoothie things you can see. Now you see this? This is what they call a rind. Now that rind is literally the fascia. It's what they call synovial sheathing and fascia. And something that I found out is unbelievable. Look at this. Everybody thinks that we're so smart, but nature is way smarter. That is, I just told you, a synovial sheathing. Now look at this. These are coefficients of friction. Synovial joints in humans are the best frictionless thing that's ever been invented. Teflon is a zillion times worse. There's look at it, it's just amazing. This stuff is fabulous, and we can't even come close to duplicating synovial fluid. So, we think we're so smart. There is no such thing as evolution and Big Bang and all this stuff. Go with God, and you'll be a lot better off, and your eternity will be a lot more pleasant. Now, look at this layer in here. Whoops. What did I do? What did I do? Here we go. You see that layering? Very, very easy. And you see blocky layer. And they'll go right down into the center. And I'm going to show you what that looks like. Uno momento. Alright, that's the stone balls I'm talking about. They're all over the earth, and they come in these huge quantities and clusters. Alright, you see them, they come in huge quantities and clusters all over the earth, and there's little things at the top are where the straps tie in. They're all over the earth. These are the same things right here, a stone ball on a strap. Alright, this is what these tendon balls look like, and as they go into ligaments, you see that they go into and I have one right here, I'm holding it in my hand, I'll show you in a second. They dig into the center in these little ligaments, and they hold the bones together. Then additionally, they go out to outside of your bone, and they go all over the place like this. Both of them work the same way, but one of them stretches between bones to muscles, and one stretches between bone to bone, the ligaments, which keep you from falling apart. Now, look at this. Here's exactly what happens. See those little tiny balls? You see that hole there? You see those little tiny holes up in that ball? That's the ligament. And that's where all the balls invest. And what I showed you before, the balls all over the earth, are giant balls from giant creatures. And that is a fact. Now, you see this here? This right here, you see that fabric? That's what wraps this. Oh, hold on a second. Yeah, wait a minute. This is what wraps all bones. They have the exact same thing. And then they have this flap that goes over the top. It's just the way they work. And that's the cartilage. You see this? This is like muscle. That's muscle that petrified, or mud fossilized. And that right there is what I call it the fascia flap, the fascia flap, and that tags in things so that it like grabs a hold of it. So you pull your muscle back and forth. It pulls your arm, and everything's in here. Every bit of the architecture of life is in here. The elastins. Everything, every single bit, the red muscle, the white muscle, all the connective tissue, there's no question what it is. And this is, it's perfectly preserved because of the mud fossil conditions.